We have this belief that complex systems are always getting better, that they're constantly evolving towards a more rational, more efficient design. But what if that belief is just fundamentally flawed? Today, we're going to explore why a system's past isn't just a memory, but an active force that very often traps its future.
So first things first, we need to dismantle a core assumption that really clouds our judgment, what we can call the myth of rational design. The basic idea we all have is that our organizations, our markets, our technologies, they're all on this constant journey of refinement, always moving toward the most efficient, most optimal design possible. And you know what? This feels right. It's totally intuitive. I mean, we look around and we see people constantly trying to solve problems and improve things. So progress, well, it feels natural, almost inevitable. But here's the thing, this deeply held belief is structurally incorrect. And it's not because people don't try to improve things, they do. It's because the very structure of systems often prevents the best solutions from ever being reached in the first place. So here's the crucial point. A system's evolution isn't guided by its future potential. Instead, it's constrained by the path it has already traveled. History isn't just a backstory here. It's the active script the system is forced to run, day in and day out. To really get our heads around this mechanism, let's use a simple physical analogy. Think about water carving a path across a landscape. Okay, so imagine a huge flat plain. It starts to rain. At this very first moment, the water could flow in any direction. The system has almost infinite freedom. There's no predetermined best path. But then something small and completely random happens. Maybe there's a tiny depression in the dirt, or a single rock shifts, and this creates a tiny initial channel. Now, it's not a better channel, it's just the first one. And this is where a powerful mechanism kicks in. More water gets drawn into that little channel, which erodes it and makes it just a bit deeper. And of course, the deeper channel then attracts even more water, which erodes it even further. You see, it's a self-reinforcing cycle, a positive feedback loop. Eventually, this process carves out a deep canyon. At this point, the water has only one path it can follow. It is locked in. And crucially, it's not locked into the best possible path, it's simply locked into the path that got started first. Any other route, even a potentially better one, is now completely inaccessible. Okay, so let's translate this physical analogy into the formal principles that govern our economies, our technologies, and our institutions. This is the mechanism of lock-in. This whole phenomenon is called path dependence, and it's a simple but really profound idea that where we can go is a direct function of where we've already been. The sequence of events matters a lot. And what this shows us is a core idea of path dependence. Small, often accidental, choices at the very beginning can have massive and irreversible consequences down the road. The system can't just hit an undo button and go back to that initial state of infinite possibility. The engine that drives path dependence is a principle called increasing returns. This is that positive feedback loop we saw with the river. In human systems, the more a technology or a standard is adopted, the more valuable it becomes. And that encourages even more adoption, creating this powerful self-reinforcing cycle. Now let's apply these ideas directly to the world of human systems, where you can feel the gravity of past decisions every single day. A classic example is something called vendor lock-in. Once a customer invests in a particular ecosystem, learning its software, buying all the hardware, storing data in its specific format, the cost of switching to a competitor becomes huge, even if that competitor's product is objectively better. And this isn't just an accident, it's often a core business strategy. Just look at this internal memo from Microsoft back in 1997. They understood that creating high switching costs through their own standard, the Windows API, was the key to survival. It made the existing path way more attractive than trying to forge a new one. And right here we see the central paradox. For any individual developer or user, the most rational choice is to just adopt the dominant standard. It has the biggest network, the most support, but when everyone makes that same logical choice, the collective, unintended result is that the standard becomes a prison, an inescapable monopoly. But the effects of being trapped in that canyon go even deeper. The lock-in doesn't just constrain our choices. Over time, it actually begins to reshape us. Just think about the QWERT keyboard. It started as a mechanical solution for old typewriters. Then it became the standard, creating high switching costs for anyone who learned how to type. Then it shaped our behavior. We all learned to move our fingers in that one specific, kinda inefficient way. But the influence doesn't even stop there. The conditioning goes deeper still. Studies have found something called the QWERTY effect. Because most of us are right-handed, words typed with letters on the right side of the keyboard feel slightly more fluent to type, and this fluency creates an unconscious bias. We actually perceive words with more right-hand letters as having a more positive emotional meaning. A technological accident now subtly shapes our very perception of language. This brings us to the final, and I think most crucial, way to reframe how we understand all the systems around us. We have to stop thinking of a system's past as just, a dead record of things that happened a long time ago.
Instead, we should see its history as the active, running source code that dictates its current behavior. Those early contingent decisions are the legacy code that the system is still executing today, whether it makes any sense or not.
So, when you see a system producing a suboptimal, inefficient, or seemingly irrational outcome, your first assumption probably shouldn't be that it's broken or that somebody made a mistake. The system isn't failing. In fact, it's working perfectly. It is faithfully executing the logic that was embedded in it at its creation. The question we should be asking is not, why is it failing, but what is the historical program it is still running?